NASA suspends quantum computer project following a mysterious event. In recent years, quantum computing has emerged as a potential game-changer for industries ranging from finance to pharmaceuticals and even space exploration. At the forefront of this technological revolution, NASA has invested heavily in quantum research, hoping to unlock new capabilities for solving complex space-related problems, from mission optimization to deep space communications. However, a recent mysterious event at NASA's quantum computing lab has forced the organization to suspend one of its most promising quantum projects, leading to widespread speculation and concern within both the scientific and tech communities. The quantum race, NASA's early successes. NASA's interest in quantum computing is driven by the promise of unparalleled computational power. While classical computers use bits, zeros and ones, to store and process information, quantum computers leverage quantum bits, or qubits, which can exist in a state of superposition, meaning they can represent both 0 and 1 simultaneously. This allows quantum computers to perform multiple calculations at once, dramatically speeding up processes that would take classical computers centuries to complete. Since the early 2010s, NASA has been at the cutting edge of quantum research, partnering with tech giants like Google and D-Wave to explore practical applications. NASA was particularly interested in quantum computing's potential to address optimization problems in space exploration, such as determining the best flight paths for spacecraft or modeling the behavior of complex systems like planetary atmospheres. Early experiments using D-Wave's quantum annealer showed promise. Quantum algorithms were able to solve certain optimization problems significantly faster than classical methods. NASA hoped these advancements could lead to breakthroughs in artificial intelligence, machine learning, and even material science, areas critical to future missions to Mars, deep space exploration, and the development of advanced propulsion technologies. The Quantum Project, NASA's ambitious plans. One of NASA's most ambitious quantum projects, codenamed Q-Probe, focused on solving space mission optimization problems with quantum computing. The primary objective was to streamline calculations related to spacecraft trajectories, gravitational slingshots, and orbital adjustments. As space missions become more complex, calculating the ideal parameters for fuel consumption, speed, and path requires tremendous computational power. Traditional supercomputers, while effective, often take weeks or months to perform these optimizations, especially when the number of variables is enormous. Q-Probe was designed to change that. By leveraging the power of quantum computers, NASA hoped to reduce the time needed for such calculations from weeks to hours. This could be a game-changer for future space missions, allowing NASA to quickly adjust to unforeseen challenges, like course corrections due to asteroid interference or rerouting spacecraft in response to changing mission objectives. The project was in the experimental stage, but early results had been encouraging. Q-Probe's team reported breakthroughs in developing new quantum algorithms, and the system appeared to perform exceptionally well in simulations. By mid-2023, NASA planned to integrate Q-Probe with its real-world mission planning systems. However, this promising endeavor was abruptly derailed by a mysterious and unexplainable event that occurred during one of Q-Probe's experiments. The mysterious event, a quantum anomaly. The incident took place during what was supposed to be a routine test of the Q-Probe system. The quantum computer was tasked with calculating the optimal flight path for a simulated mission to Europa, one of Jupiter's moons, using real-world parameters. The test started as expected, with the system processing data at remarkable speed. Then, something went wrong. According to insiders, the quantum computer began producing nonsensical results, outputs that defied logical interpretation. While quantum computers are known for their ability to explore multiple possibilities simultaneously, the system's calculations deviated in bizarre ways. The final output suggested trajectories that not only ignored the fundamental laws of physics, but also contradicted the input data fed into the system. At first, NASA's scientists suspected a minor coding error or a glitch in the hardware. But upon further investigation, they found no trace of traditional technical issues. The hardware was operating within normal parameters, and the algorithms had been thoroughly tested in previous simulations. But the anomalies didn't stop there. As the team attempted to reset the quantum computer, the system began exhibiting erratic behavior. Some reports suggest that it briefly entered a state of quantum entanglement with other systems, creating unexpected interference with neighboring computers, which were not even involved in the experiment. Data from other unrelated experiments began to show signs of corruption, causing widespread concern among the research team. NASA's engineers immediately shut down the quantum computer to prevent further potential damage. However, this was just the beginning of the mystery. The aftermath, a chain reaction of unexplained failures. The shutdown of Q-probe should have stabilized the situation, but instead, NASA began encountering more problems. Over the next 48 hours, the research facility experienced a series of unexplained system failures. Several servers, which were not directly linked to the quantum experiment, crashed unexpectedly, and data logs from the Q-probe tests became corrupted. Even more perplexing, some of NASA's satellite communication systems, which were running on entirely different networks, began to show minor anomalies. The timing of these disruptions aligned closely with the events surrounding Q-probe's shutdown, raising suspicions that there could be a deeper connection. One of NASA's engineers, who asked to remain anonymous, described the situation as a cascade of failures that we could neither predict nor control. The anomalies were not consistent with any known issues related to quantum computing, leading some to believe that the quantum system might have triggered a previously unknown phenomenon. Speculation quickly spread within NASA's scientific community. Some suggested that the quantum computer may have entered a state of decoherence, where the qubits lose their quantum properties due to environmental interference. Others proposed more radical ideas, such as the possibility that the quantum system had unintentionally tapped into a phenomenon beyond current scientific understanding. Theories and speculation. What really happened? As word of the mysterious event spread, several theories began to emerge. One theory is that the quantum computer may have encountered a quantum ripple, a speculative idea in which a quantum system becomes entangled with physical environments in ways that classical computers cannot detect. While there is no hard evidence to support this theory, it has sparked interest within the physics community. Another popular theory revolves around the possibility of a quantum tunneling event. Quantum tunneling is a well-documented phenomenon where particles can pass through barriers that would be impossible for them to overcome under classical physics. Some researchers believe the Q-probe may have triggered an event that allowed it to access quantum states that disrupted the stability of the surrounding classical systems. There are also darker theories. Some have questioned whether the incident could have been caused by an external actor. Could someone have intentionally tampered with NASA's quantum system, attempting to sabotage its operation? Given the sensitive nature of NASA's quantum research, cybersecurity remains a top priority. However, NASA has so far not released any information suggesting foul play. NASA's decision to suspend the project. Faced with mounting uncertainty and no clear explanation for the mysterious event, NASA made the difficult decision to suspend the Q-probe project. This suspension, while temporary, is significant. NASA has invested millions of dollars and years of research into quantum computing, and the Q-probe project was considered one of its most promising ventures. In a press release, NASA stated, "We have temporarily suspended the Q-probe quantum computing project following an unexplained event during testing. Our team is investigating the situation thoroughly, and we are committed to ensuring the safety and integrity of our systems." Quantum computing represents a frontier in technology, and with any frontier comes unknown risks. We will resume the project once we fully understand what occurred. The suspension is a major setback for NASA, especially since Q-probe was nearing the integration phase with actual space mission planning. This pause has also triggered a broader review of NASA's quantum computing infrastructure. The agency is working with external experts in quantum physics, cybersecurity, and systems engineering to diagnose the root cause of the incident and ensure that any future projects are safeguarded against similar events. The larger implications for quantum computing. NASA's suspension of Q-probe is not just an isolated incident. It has sparked a larger conversation about the risks and challenges of quantum computing. As one of the most advanced quantum systems in operation, Q-probe's mysterious event has highlighted the potential dangers of pushing this technology into uncharted territory. Quantum computers operate on the principles of quantum mechanics, a realm of physics that is inherently probabilistic and often counterintuitive. While these systems offer unparalleled computational power, they are also highly sensitive to environmental factors such as temperature, electromagnetic interference, and even cosmic radiation. NASA's quantum computers are kept in cryogenic conditions to maintain the delicate balance needed for qubits to function, but even slight disturbances can have dramatic effects. The Q-probe incident underscores the unpredictability of quantum systems. As researchers continue to explore the capabilities of quantum computing, they must also confront the possibility that these machines might interact with the physical world in ways that classical computers do not. The event at NASA serves as a reminder that the potential for unknown consequences remains high. The future of quantum computing at NASA. For now, the future of quantum computing at NASA remains uncertain. While the agency has suspended Q-probe, it is unlikely that NASA will abandon quantum research entirely. Quantum computing represents a new frontier in computation, and its potential benefits for space exploration, AI, and material science are too great to ignore. However, NASA's experience with Q-probe will likely lead to a more cautious approach moving forward. The agency is expected to implement stricter safeguards and error correction techniques in future quantum systems. This includes refining algorithms to detect anomalies earlier and incorporating redundancy into quantum systems to prevent cascading failures like those seen in the Q-probe incident. In addition to technical improvements, NASA may also increase its collaboration with other institutions to better understand the fundamental nature of quantum phenomena. Universities, private tech companies, and government agencies around the world are all exploring quantum computing, and NASA's experience could serve as a valuable case study in mitigating risks. Conclusion: a setback, but not the end. NASA's suspension of the Q-probe quantum computing project marks a significant moment in the development of quantum technology. While the event that led to the suspension remains shrouded in mystery, it has highlighted the need for caution as researchers push the boundaries of what is possible with quantum computers. The unknown risks associated with quantum computing are real, but so are the potential rewards. As NASA investigates the root cause of the mysterious event, the global scientific community will be watching closely. This incident could shape the future direction of quantum research, not just for NASA, but for the entire field. Despite the setback, quantum computing remains one of the most exciting and revolutionary technologies of our time. The path forward may be uncertain, but the promise of quantum computing is far from over.